Right, validation. In the last few episodes, we've looked into property wrappers and what they are and how to use them and things like that. In this episode, we're going to make our own property wrappers to really solidify those concepts. So if you haven't seen those episodes, go back and watch them before watching this one, because again, we're going to be building on what we've learned. But let's get into this. And in front of us, we've got pretty much where we left off in the last episode with a couple of changes. I've changed the order of the users there to something more appropriate. If you can tell me why I've chosen that particular order, let me know in the comments. I'd be very impressed. In addition to that, I've added some validation to this. So as you can see, if I click on Judd here and try to change the age to a negative value, I can no longer do that. All right, and I can also not go beyond 150. Now, I thought 150 was future-proofing the application enough, but let's bring that down to something a bit more sensible, but we'll do that as we go on. Now, how have I done this validation? Let's go down to the implementation of Edit User, and here you can see there's nothing obvious when I'm actually changing the age. As we go further down, you can see at the bottom there that there's a ValidateUser function. That is being called in the onChange modifier that we touched upon in episode 2. Here, I am clamping the age of the user to somewhere between 0 and 150. The clamp function is an extension on int. It takes a from value, a to value, and makes sure that the value of the int itself lies somewhere in that inclusive range. And because the user can't enter something that's incorrect, we don't have to worry about validating it when they click OK or anything like that. So what we're going to do is extract that clamping into a property wrapper that we can then use in the user struct itself. So let's get busy with that. Just below the user, we're going to add a property wrapper. And denoting something as a property wrapper is as simple as annotating it like this. At property wrapper. So now the struct that we declare is going to be a property wrapper and has to adhere to the constraints of what it means to be a property wrapper. As we learned in episode 1, the only mandatory requirement is to have a property called wrapped value. Private struct clamped int, and we need a property called wrapped value. In this case, it's an int. When we set the value on this thing, we want to make sure that it only sets it if the value is within the clamp. When we get it, we just return this value that we are controlling. And my own personal preference, and for consistency, is to have the internal value be underscore wrap value and private. So let's just put that one in. Private var underscore wrapped value, and we'll make that an int. Now, as you can see, I'm using integers specifically for this clamped property wrapper. Later on, we'll make it a bit more flexible by making it generic. But in the meantime, we're just going to deal with ints to keep things as simple as possible, even though the difference isn't that stark. Now, I haven't finished with the wrapped value property there. We can't implement that though unless we know which values we're clamping between. So let's put those in now. Private let from, which is an int, and to, which is also an int. And now that we've got that set up, we can control the value that is passed in. For the getter, all we're going to do is return the wrapped value. But for the setter, we need to make sure that the value that we get is between from and to inclusive. So we say the wrapped value is the new value, and then we use that nice extension to make sure the value is from, and to. Okay, so now we know that the new value is going to be appropriate. We do have a little problem here. There is currently no way to initialize this property wrapper, so we can't annotate a property with it and initialize it on assignment or anything like that until we add one that at least takes a wrapped value as a parameter. Let's add that initializer now. Init, and remember, we need that wrapped value parameter there for the magic of property wrappers to be able to initialize this property wrapper on assignment. And it needs to be the first parameter. You can put other parameters in there, which you can then initialize as we'll see a bit later on. So that is an int. We also need a from value. And because I don't want to have to set it, I'm going to set it to the minimum integer value. The to, we're going to default to the max value. So by default, it doesn't actually limit the integer that is passed in. So we can then assign from, to goes to 2, and then we can duplicate this, move that one up to our initializer, and then we change new value to wrapped value. And now the wrap value that's passed in is also restricted to that range. We're not quite done with this property wrapper yet. As you can see, the user is equatable. And what that means is that its properties also have to be equatable in order for this synthesized equality to actually do its job. At the moment, this property wrapper is not equatable. So let's make it conform to that, equatable. But I'm not going to take the synthesized equatable implementation for this, because all we care about is that the wrap value is the same as another clamped wrap value, because we want this property wrapper to act as though it is an age in this case. To do that, I'm going to implement the equality myself. Static func equals equals. The left-hand side is of type self. The right-hand side is of type self. This returns a Boolean. And all we do is we say left-hand side wrap value equals the right-hand side wrap value. And now we are done with this property wrapper, but you might be shouting at the screen saying, why haven't I implemented the projected value? And that's because I don't have to. You're not compelled to do that. And because there's nothing really clever going on in this property wrapper, what would I actually expose as the projected value? I mean, it can be anything you like, but what would it be that would actually be useful? I can't really think of anything, so I haven't implemented it. Now we're going to actually use it in our user. So let's see what that looks like. I'm going to go up to our age property here, and I'm going to make that a clamped int, at clamped int. And this is where you can use the initializer that takes a from and to. I can put in just the from and to parameters here, like this. From, let's say 0, to, let's go to 100 this time. And then, because I want to use that initializer, I need to provide it with a wrapped value. So let's just set it to 0. Now at this point, we've got a user that will clamp the age. But at the moment, it's using the validation that we had in there originally. Here we are using the onChange event to validate the user. I'm just going to remove that. And I'm going to remove this ValidateUser function here, so you know that I'm not cheating. And then I'm going to resume. And now if I click on Ali and try to change her age to beyond 100, it does not work. And I cannot go below 0 either. We can cancel that and everything is working as we expect. Let's go back up to our clamp here and make it more generic, because at the moment it obviously only supports ints. First of all, let's duplicate the whole thing and we'll call this one clamped. This thing is going to be generic over T, and because we're going to be doing some comparison, we need T to conform to comparable, just like that. And now we can go to our ints and change them to T. But we have a little problem when it comes to the default values. We don't want this range to be compulsory, but we can't have a generic default value before we set from to the minimum value of int, but we can't do that for generics. So what we're going to do instead is make them optional. The from is going to be optional, the to is going to be optional, and then we're going to set the default values to nil. So they don't have to provide them. Okay? That's our clamped property wrapper written, but of course we don't have a clamped extension for comparable. So let's define that where we define the clamped extension for int. Here we are, and just below the extension for int, we're going to make the one for comparable. Private extension comparable. Same name as the other one. And the from is of type self, which is optional. And the to is of type self, which is also optional. And we're going to return the type of self. And the value we're going to manipulate, clamped value, is equal initially to the value of self. And now we say that if we have a from, clamped value is equal to the maximum value of the clamped value and from. Next, we'll check the to. If there is one, then we'll clamp the value again, but we want it to be the minimum of the clamped value and to. Lastly, we return the clamped value. So now we have an extension on comparable that we can use. This should at least build, fingers crossed. And it does. Wonderful. And then we can go back up to our user here. And instead of clamped int, all we need to do is change it to clamped. And you know, I don't think we even need this. What was I thinking? Let's resume and see if our new generic clamping works. Emilio Can we go over 100? We can't. And can we go below 0? We also cannot do that. Wonderful. Our clamping is working. It's totally generic for anything that is comparable. And we've cleaned up our code significantly. So we can now get rid of this. And in the next episode, we're going to be working on the name validation. At the moment, you can pretty much enter anything you like for the name, including numbers, which is absolutely not what we want. So we're going to be looking at the name validation, and because we are now dealing with states that the user can control, as in the user can enter incorrect values that they need to know about, it's more involved because we have to deal with error conditions and how we display those errors and how we respond to them. So join me for that. It's going to be brilliant. If you're liking this series, let me know by hitting the like button. It really means a lot. And if you don't want to miss the next episode and you're not subscribed, consider doing that, and there's at least a chance that you won't. If you have any questions, comments, or suggestions, please leave them below. But in the meantime, thanks for joining me. See you next time.